Welcome to Session 9, Scatterplots and Lines of Best Fit. A scatterplot shows how two quantitative variables move together, but association alone does not prove causation. 10 real examples will cover positive, negative, and unclear association, interpolation and extrapolation, fitted line prediction, outliers, confounding variables, balance around a line, and association strength. Describe direction, form, strength, and unusual points before using a fitted line. Interpret predictions cautiously and stay inside the observed range when possible. Example 1. A scatterplot compares weekly study hours with exam score, and the points rise from lower left to upper right. Describe the association. The scatterplot reveals direction, strength, and any unusual point. Plan. State direction, variables, and cautious meaning. Step 1. As study hours increase along the horizontal axis, exam scores tend to increase vertically. Step 2. The overall direction is upward. Step 3. Therefore, the plot shows a positive association. Step 4. A careful interpretation is that students who studied more tended to earn higher scores. Quick check. The wording "tended to" allows individual points to differ from the overall pattern. This matters in real life because schools use association patterns to identify study habits worth investigating further. Example 2. A scatterplot compares outdoor temperature with home heating use and slopes downward. Interpret the direction. The scatterplot reveals direction, strength, and any unusual point. Plan. Describe how the response variable changes as the explanatory variable increases. Step 1. Outdoor temperature is the explanatory variable. Step 2. Heating use is the response variable. Step 3. As temperature rises, heating use tends to fall. Step 4. The variables have a negative association. Quick check. A negative association means opposite directions, not that either variable has negative numerical values. This matters in real life because energy providers forecast seasonal demand from temperature relationships. Example 3. Points comparing shoe size with quiz score form a shapeless cloud. What conclusion is supported? The scatterplot reveals direction, strength, and any unusual point. Plan. Look for a consistent upward, downward, or curved pattern. Step 1. The points do not rise or fall consistently. Step 2. Large and small shoe sizes appear with many different scores. Step 3. There is no clear association in the sample. Step 4. Shoe size would not be a useful predictor of quiz score from this plot. Quick check. No clear association is a valid finding. Do not force a line through random scatter. This matters in real life because recognizing unrelated variables prevents organizations from building meaningless predictions. Example 4. Delivery model is predicted time equals 3x plus 12, where x is distance in miles. Predict a 7-mile delivery. The scatterplot reveals direction, strength, and any unusual point. Plan. Substitute the given distance into the model and retain units. Step 1. Substitute. X equals 7. Predicted time equals 3, 7, plus 12. Step 2. Multiply. 3, 7, equal 21. Step 3. Add. 21 plus 12 equal 33. Step 4. The model predicts 33 minutes for a 7-mile delivery. Quick check. The 12-minute base plus 3 minutes for each of 7 miles gives 33 minutes. This matters in real life because delivery platforms use simple models to provide customers with estimated arrival times. Example 5. A line of best fit uses data from ages 18 through 65. Is predicting age 42 interpolation or extrapolation? The scatterplot reveals direction, strength, and any unusual point. Plan. Compare the prediction input with the observed input range. Step 1. The observed ages begin at 18 and end at 65. Step 2. Age 42 falls between 18 and 65. Step 3. The prediction stays within the measured range. Step 4. Therefore, it is interpolation. Quick check. Interpolation is generally safer because the model is being used where evidence was observed. This matters in real life because insurance and health models distinguish purported in range predictions from riskier extrapolation. Example 6. A sales model was built from advertising budgets between $1,000 and $10,000. Explain the risk of predicting sales for a $100,000 budget. The scatterplot reveals direction, strength, and any unusual point. Plan. Compare the requested input with the data range and identify assumptions. Step 1. $100,000 is far outside the observed $1,000 to $10,000 range. Step 2. The prediction would be extrapolation. Step 3. The relationship may flatten, change, or be limited by market size at larger budgets. Step 4. The model can calculate a number, but the evidence does not make that distant number reliable. Quick check. A warning about model validity is part of a complete answer even when arithmetic is possible. This matters in real life because businesses avoid expensive decisions based on trends extended far beyond observed conditions. Example 7. Most points follow a tight upward pattern, but one point lies far below the trend. How should it be treated? The scatterplot reveals direction, strength, and any unusual point. Plan. Identify the point as unusual, then consider data quality and context before removal. Step 1. The point is an outlier relative to the main scatterplot pattern. Step 2. First check for recording, unit, or matching errors. Step 3. If valid, investigate whether it represents a special case. Step 4. Report how the point may affect the fitted line rather than deleting it automatically. Quick check. A legitimate unusual observation is evidence, not an inconvenience. This matters in real life because quality teams study outliers because they can reveal failures, exceptional success, or data entry problems. Example 8. A scatterplot shows that neighborhoods with more firefighters have more fire damage. Does this prove firefighters cause damage? The scatterplot reveals direction, strength, and any unusual point. Plan. Separate association from causation and look for a lurking variable. Step 1. The plot shows a positive association between firefighters and damage. Step 2. Large fires cause both greater damage and a larger emergency response. Step 3. Fire size is a likely confounding variable. Step 4. The graph does not support the claim that firefighters cause the damage. Quick check. A plausible third variable can explain an association without the proposed causal direction. This matters in real life because emergency policy decisions require study design and context, not correlation alone. Example 9. A line of best fit has roughly equal numbers of points above and below it. Why is that desirable? The scatterplot reveals direction, strength, and any unusual point. Plan. Connect a best fit line with balanced prediction errors. Step 1. Points above the line have actual values greater than predicted. Step 2. Points below have actual values less than predicted. Step 3. A balance suggests the line is not systematically too high or too low. Step 4. The line summarizes the center of the cloud reasonably well. Quick check. The line need not pass through every point. Its purpose is to summarize the overall trend. This matters in real life because balanced models help planners avoid consistently overestimating or underestimating outcomes. Example 10. Two scatterplots both rise. Plot A has points tightly clustered around a line. Plot B has points widely scattered. Which has the stronger association? The paired scatterplots make association strength easy to compare. Plan. Compare how closely points follow a consistent form. Step 1. Both plots have positive direction. Step 2. Plot A's points stay close to a common line. Step 3. Plot B shows much greater vertical variation around its trend. Step 4. Plot A has the stronger linear association and usually supports more precise prediction. Quick check. Strength refers to closeness to a pattern, not the steepness of the line. This matters in real life because model users assess strength before deciding how much confidence to place in predictions. Session 9 recap. Positive association rises, negative association falls, and no clear association has no consistent direction. Strength means closeness to a pattern, not steepness. Interpolation stays inside the observed range. Extrapolation goes beyond it and is less reliable. Association is not causation. Quick check. A model was built for ages 18 through 65. Is a prediction at age 40 interpolation or extrapolation? Age 40 is inside the observed range, so the prediction is interpolation.